Number 12. They're asking for the one that does not describe the cart's motion. So I'm looking for the one that is not true. The cart moved 24 meters away from the starting point between 2 and 5 seconds. So I have to look at 2. Let's say it's at about 2. At 5 seconds, about 26. 26 minus 2. That gives us 24. Even if you didn't get exact numbers, if you got 23, 22, they're not far off. That's your margin of error. That'd be fine. So that's good. The cart moved toward the starting point at a speed of 3 between 7 and 12. So I have to look at 7. 7's about 26. 12. What is it? 10, 11. So 26 minus 11. 5, 15 divided by 12 minus 7, 7, 8, 9, 10, 11, 12, 5, 15 divided by 5, that's 3. So that checks out. Again, if you got 2.8, 2, anything like that, you're fine. That's a margin of error. That's not far off. The cart moved 11 meters toward the starting point between 8 and 10. 8, that says about 23. 10, let's say that's 16. 13. So 7 and 11. That's not close. That's a big margin of error. So 11 doesn't look right, but we're going to check the last one just in case. The cart moved away from the starting point at a speed of 1 meters per second for 2 seconds. So we said 2 is at 2. Speed is distance divided by time. 2 meters, 2 seconds. That checks out. That's 1. So my answer has to be H. H did not work out. You have to look at your graph. Write on your graph. Move it to make sure you're looking at the right spots. 13. Which elements have similar properties? If they have similar properties, they're in the same group. So they're asking you which one is in the same group. Well, let me see how many valence electrons, because the group number equals the number of valence electrons. So 1, 2. So I'm looking for group 2. Let's tear this off. Group 2, beryllium. So those check off. Magnesium, calcium, scronium, barium, radium. It has to be A. This isn't a hard question, but you have to know what similar properties. You have to know how to find the group number. This was a multi-step problem, so slow down and take your time. Number 14. Which statement describes the velocity? So let me think. Velocity is speed and direction. The apple moved a distance of 6 meters in 3 seconds. That's true, but there's no direction. The speed of the apple was constant at 1.75 meters per second. Okay, there's no direction. The speed of the apple did not change. Okay. The apple fell in a downward motion at an average speed of 2 meters per second. Oh, look, there's that direction. There's no direction here. Okay. This one was basically just a definition question. Do you know what speed and direction is? Velocity. Okay, and that's why we went over that on that PowerPoint. Slow down. Because these are true. Oh, no, this one's not true. But this is true. Don't pick this one. It's true, but it doesn't answer the question. It doesn't describe velocity. And that's what they'll do. They'll give you true statements that do not answer the question. Take your time. What is the number of neutrons in potassium? Mass minus atomic number equals neutrons. So let me find potassium. 39 minus 19 equals 20. According to this section, which of the elements are most reactive? Group 1 and 17 are highly reactive. 1, hydrogen, lithium, here's a lithium, sodium, potassium, that's it. G. How does the reactivity of chlorine compare to sulfur and argon? Pi ver. If they're asking about the reactivity, they're really asking about their valence electrons. Valence electrons equal reactivity. So let me see, chlorine has 1, 2, 3, 4, 5, 6, 7. If he has 7, what is his reactivity? Well, let me think. Group 1 and 17 are highly reactive. So if he's in 17, chlorine is highly reactive. So let me look at sulfur. Sulfur is in group 16. Argon is in group 18. What do I know about 18? He's a noble gas, meaning he is stable. He does not react. He has all 8 already. Chlorine is less reactive than sulfur. Oh, he can't be less. Chlorine is more reactive compared to sulfur and argon. Okay. Chlorine is not least. Chlorine has the same. Oh, no, my answer has to be B. He does not react, and he isn't as reactive because he's not in 1 or 17. So chlorine's going to be the most reactive. Oh, this keeps happening to me. Number 18. Which activity would best demonstrate Newton's laws of force and acceleration? Roll a tennis ball across a smooth surface and rough surface. The tennis ball rolls farther on the smooth surface because there is less friction. Anytime you see the words friction, continue, stays. That's the first law. That's inertia. Remember, we saw the marble. We move the marbles. Friction stops them. Friction is inertia. Fasten your seatbelt securely in a vehicle. Ask the driver to speed up and then brake suddenly. Feel how your body would, oh, there's that word, continue. That's inertia. Roll 2 balls toward each other with the same speed on a smooth surface. When they hit each other, they move in opposite. If there's opposite, that's action, reaction, like the rocket and the balloon. The rocket goes up, force, the exhaust goes down. They're opposite directions. Push, that's a force, a small student desk and then a large cafeteria. More force because it's greater mass. That's second law. And this is on page 11 if you need to review. Which of the following models is most reactive? There's that reactive again. Use the verb. Valence electrons equal reactivity. What I know about that 1 and 17, they're asked about the most, so I'm going to put that they're the ones that are highly reactive. So I'm looking for 1 valence electron and 7 valence electrons. That's what I'm looking for. One, 2, oh, you're at the picture. 1, 2, 3, out. 1, 2, 3, 4. My answer has to be A. The student applies the same amount of force to each cart and then calculates the acceleration. Which statement correctly explains how Newton's second law compares the acceleration of the two carts? So I have to see. More mass, less mass. It's the same force. So there's more mass, that's less acceleration, they have the same force. Less mass is more acceleration. If you need help with this, it's on page 11. Cart A will accelerate slower. That's not what we said. Cart A will accelerate faster. Cart B will accelerate faster. We said it's going to be less. Cart B will accelerate slower. Okay, that's true. So now I have to look at that second part. Then cart B, because cart A has more mass. Does A have more mass? Because it has more, cart B has more mass. Do you see how they gave you that first part is true? Then they made the second one wrong, and look where they put it. They're putting it first. It can be like, oh, that's true. Let me circle and keep going. Slow down and keep reading. Whenever they have those two-part sentences, look at the first part first. Then go back and look at the second part. Because here I only have to look at 2 of the second part versus looking at all 4 second parts. So just when they do this, slow down, separate your sentences. Look at that first part, then move on to the second part. 21. Now this one we did talk about speed. We didn't quite talk about the average speed. So if you missed that one, that's something we just covered real quickly. It's not hard, so hopefully after this you can get it. They're asking you for the average speed. Anytime I want the average of the speed, I want all of it. I want to know what the average was for the whole line. So if I want the whole line, I'm going to have to come to the end. If I stop right here, that just gives me this part. If I stop over here, that just gives me this. I have to get the whole thing, so I'm coming to the end. Speed equals distance divided by time. Distance, time. 10 divided by 50. Top in, bottom out. The answer should have been 0.2. Again, be careful when you bubble. Make sure it's behind that decimal. Because if you put it like this, it's going to be wrong. The answer was 20 cents. You put $2. So make sure you slow down and check your decimal. 22. Which car completed the race with the fastest speed? Speed is distance divided by time. 60 divided by 3. 120 divided by 6. 270 divided by 9. 300 divided by 12. 20. Let me get my calculator again. Let me check that one first. 60 divided by 3. That is 20. 120 divided by 6. I think that's 22. Yeah, that's 20. 270 divided by 9. 30. 300 divided by 12. 25. I'm looking at why. They had the fastest speed because he was 30. This one I kind of started looking at. Miss Frizzle poses an engaging question to begin the force of motion unit in her 8th grade science class. 2 cars, so I'm going to underline this because this is what she said. 2 cars with different masses travel at the same speed down a hill toward a stop sign. What will happen to both cars when you apply the brakes at the same time to stop? Below are some responses. The car with the smaller mass will require less force, less mass, less force to stop the car than the larger mass. The car with the larger mass will maintain its velocity while traveling down a hill. If you go down a hill, you know it's not going to maintain. It can't stay the same. Because when you go down the hill, you're going to go faster. The car with the smaller mass will take longer to stop. Remember we looked at the marble and the BB. The marble stays spinning longer because it had more mass, more inertia. So if it had the smaller mass, it would take a shorter amount of time. The car with the larger mass will have less inertia. More mass, more inertia. So my answer has to be student A. Student A is correct because the car with the smaller mass requires less force. Less mass, less force required. The more mass, the more force required. This was a simple Newton's Law question. They just try to make it confusing with all the reading. Just slow down and look what it's asking for. At this time, we've come to an end. Go ahead and read the next Google post about your tracker for your benchmark. So go ahead and take this part out, and you're going to watch the next video to tell you what to do next.